Okay, Assalamualaikum warahmatullahi wabarakatuh dan very good afternoon. So today lecture will be recorded for all of you. Okay, we will continue from previous topic, which is force in a plane 2D. Alright, we're still in chapter 2, which is a static of particle. Right, so this static of particle, we have actually 4 subtopic. Okay, we have actually 4 subtopic, which is a force in a plane 2D. Right, so last week we have covered this scalar vectors, vector operation, vector addition of forces, addition of a system of coplanar forces. Then this week, we will cover equilibrium in a plane 2D, which is contain free body diagram and also coplanar force system. Right. Basically, for you, BNR17003, we will not cover for 3D. Okay, we just cover 2D only. Alright? Alright. We proceed. Okay. So for this equilibrium of a particle in 2D, the objective, student will be able to draw a free body diagram, okay, which is we call FBD, and also apply the equation of equilibrium to solve a 2D problem. So the learning topic is what, why, and how of a FBD, and also equation of equilibrium and analysis of spring and pulleys. So the reading quiz here, you can try to read the quiz and answer the questions. When a particle is in equilibrium, the sum of forces acting on it equals. You can choose the appropriate answer. Is it a constant, a positive number, 0, negative number, or an integer? Okay. When a particle is in equilibrium, the sum of forces acting on it is equal to, actually, it is equal to 0. Sorry. This one. 0. Okay. Right. For a frictionless pulley and cable, in the tension in the cable, okay, this T2 and T1, okay, can be related as, you can answer it as B. Okay, T1 is equal to T2 because it is a frictionless pulley and cable. Alright? Right. The application we can see for this FBD, actually, you can see through this figure for a spool of given weight, right? We have a spool with given weight. What are the forces in the cable AB and AC? Okay. What is the force that apply at this AB and AC? How we can measure the forces? And we need to apply this FBD and also the equation of equilibrium to solve this, to determine these forces AB and also AC. So in this topic, we will learn how to solve this. Also, for a given cable strength, what is the maximum weight, okay, that can be lifted? Right? What is the maximum weight that can be lifted by this tension cable? By this cable, alright? So, equilibrium of a particle in 2D, alright? This is an example of a 2D or coplanar force system. If the whole assembly is in equilibrium, dimension of if the whole assembly, right, is in equilibrium, then the particle A, right, this particle A, right, is also in equilibrium. Right, take note this one. When the whole assembly is in equilibrium, so this particle A is also in equilibrium. So to determine the tension, okay, to determine the tension in the cable, okay, which is AB, right, AC and AD, okay, for a given weight of this engine, alright, we need to learn how to draw the FBD and apply the equation of equilibrium, right? Two things you need to remember or to concern for this topic. You need to know how to draw the FBD, and also you need to know how to apply the equation of equilibrium. Alright, the what, why, and how of free body diagram. Okay, this free body diagram are one of the most important things for you to know how to draw and use. Okay, this is the most important things, okay, for you to know how to draw and use. Okay, kat mana nak guna, okay, dan macam mana nak guna. Alright, so what is FBD? It is a drawing that shows all external forces that acting on a particle. Okay, this is your FBD, right? It is a drawing that shows all external forces that acting on a particle. Particle A awak tadi ni kan? Alright? Okay, this is a drawing that shows all external forces acting on a particle. Then why? Because of this FBD, it helps you, right, to write the equation of equilibrium that used to solve for the unknowns, usually, okay, for the force or angles. Okay, sebab apa dia akan diguna pakai untuk you write down equation of equilibrium to solve for the unknowns. Okay, sama ada selalunya forces ataupun angle. Angle kita tak tahu kan. Okay, so equation of equilibrium selalu kita akan tulis E of E. Okay, alright. So how, macam mana nak lukis free body diagram? First, you must imagine, okay, kena imagine the particle is to be isolated or cut free from its surrounding. Okay, you must imagine this particle is to be isolated or cut free from its surrounding. Okay, right, this is your condition. Okay, condition. Okay, so then show all the forces that act on your particle. Okay, this one is your particle A kan. Okay, you imagine yang dia cut free ataupun free from its surrounding. So you akan draw, actually selalu kita akan draw x, y axis dulu. Kita letakkan paksi A tu, sorry, particle A tu dekat titik tengah paksi x and y. Alright, so this punya particle A tadi. Okay, and then you show all the forces yang acting pada particle A tadi, which is you have AB, right, betul, which is a tension B ataupun force AB. Okay, and then you have force AD, which is tension D, TD ataupun force AD, and also you have the weight of the engine tadi kan. Okay, make sure weight is in unit Newton. Alright, if you are given in kg, it is a mess. You need to convert to weight. How? Weight is equal to mg. So you need to multiply dengan gravity punya value 9.82. So you are given mass in kg, then you must multiply with the 9.82. Okay, 9.81 if I'm not mistaken, sorry. Then you must know that the rules or the condition for the active force. Okay, active force is they want to move the particle, which is dia nak tarik lah, right, which is in tension, right. The reactive force is they tend to resist the motion. Okay, third, then you need to identify each force and show all known magnitudes, okay, and direction. Show all unknown magnitudes and or direction as variable. Okay, so maknanya kat sini kena tulis lah this value of the weight kalau diberi, this value of FAD if given, okay, angle 30 kena tunjuk, okay, if FAB or TB if given, of the magnitudes of value you need to write down. Add for this FBD. This is your FBD. You need to know this one. Okay, this is your FBD. Simple, right? So, how to write the equation of equilibrium? So, since this particle is in equilibrium, the net force at A is 0. Okay, is given, right? Okay, since particle A is in equilibrium, okay, the net force at A is 0. Okay, the net force dekat A ni is 0. So, FAB, okay, plus FAD plus FAC, which is you punya weight tadi kan, is equal to 0. Ataupun summation of forces is equal to 0. So in general, for a particle in equilibrium equal to summation of force equal to 0 or summation of Fxi plus summation of Fyj is equal to 0 0i plus 0j. This is a vector equation. Alright, remember your last lecture sebelum ni, a vector equation, we use VCN, vector notation addition, VCN, ing, right? So, or written in a scalar form, which is summation of fx equal to 0 and fx equal to fy equal to 0. These are two scalar equations of equilibrium. They can be used to solve up to two unknowns. Okay, for two scalar equation, okay, two scalar equation which is fx and fy ni, okay, this can be solved up to two unknowns only. Okay, remember, two scalar equation of equilibrium ni only can be solved up to two unknowns. Okay, maximum. Okay, kalau dua scalar equation boleh solvekan dua unknown sahaja. Alright. So in an example, we try take a look for this FBD, right? You have this figure, right? This figure, then you need to transform it to FBD, right? First, apa? You kena pastikan this particle is cut free from its surrounding, okay, ataupun be isolated. So A awak dekat sini kan? Okay, you kena pindahkan. Okay, this drawing ni pada paksi X dan Y. Okay, kita letaklah senang ambil paksi X dan Y. Letakkan titik A ni, okay, particle A dekat tengah-tengah ni, dekat center paksi X dan Y ni lah. And then you draw force yang terlibat pada figure ni. Right, you ada TD ataupun okay, ataupun FAD. Tadi kan saya dah draw sebelah tadi kan. Right, you have TB ataupun FAB. Okay, you have the weight given direct ke bawah di paksi Y. We have 2.452 kilonewton. Okay, the weight. Alright, so how to write the scalar equation of equilibrium given? Okay, kat sini awak nampak given is the weight is 250 kg. You need to convert to weight, which is weight is equal to mg. So this 250 kilogram need to multiply with 9.81. Okay, so this is the FBD at A. Right, so write the scalar equation of equilibrium. First step is you need to consider. First step, you kena consider paksi X. Alright, paksi X, apa force yang terlibat pada paksi X? Alright, you have FAB ataupun TB dan juga you have FAD. Alright, so kena letak notation yang ini, penting sangat. This notation, okay, penting. You kena letak, okay, anak panah ke kanan you adalah positif. So, summation of force yang terlibat pada paksi X equal to what? Okay, kena ambil dan kena consider dia dekat kuadran mana. Okay, ataupun anak panah tu berada di mana. Alright, so you nampak kat sini kan FAB, dia berada di kanan, betul? Di kanan X. So, dia positif. So, kena lie down kan ataupun kena represent force AB pada paksi X. So, you have TAB atau FAB tadi cos 30. Kalau awak guna trigo, TAB dekat sini is FAB ataupun TAB cos 30. Okay, and then you nampak force AD ni ataupun tension D ni is to the left. Dia tak ada angle kan. Okay, so dia just TD atau force AD minuskan dengan FAD ataupun TD is equal to 0. Then settle for